किया हूँ मैं, लाइव गया
A very good morning to everyone. Welcome to day 2 of Epsilon 2022. I am Sairaj Pakir, Technical Head at IEEE SIESGST.
Hi, I'm Srishti Jhinge, Publicity Head at IEEE SIESGST. We are honored to be a host for this session. The IEEE SIESGST's Epsilon 2022 conference is back with a renewed emphasis on disseminating technical information centered on our theme of the Internet spectrum. In the last webinar under IEEE Track, Mr. Sigmund Holz enlightened us on blockchain, Web3, DeFi application security. If you have missed this session, you can watch it on our YouTube channel.
Under the IEEE track, we anticipate this hands-on workshop on Solidity, the backbone of blockchain, where we provide you with an abundance of information on Solidity and smart contracts and introduce you to many new ideas. So now let us begin with our most awaited session by welcoming a guest speaker for the day.
We are honored to present to you our speaker for today, Ms. Sweta Shaw. She is a postgraduate from IIT Bombay, is a full-stack blockchain developer with experience in working with 10 plus EVM protocols. She has expertise in writing secure smart contracts and ship pool DApps. As a member of developer DAO, she has also contributed significantly to the ecosystem. She has also provided training to 100 plus executive professionals and mentor students for Solidity cohorts.
Yes, ma'am. Welcome. We are very grateful to have you with us today and are looking forward to this incredible session. Also, just a little information for the attendees. This session will be go on for 90 minutes before the Q&A session. We will be sending a link for the project in the chat box during the last few minutes of the session. And the form will be open till Monday midnight. This project will earn you points, and if you land yourself in one of the best performers, you also stand a chance of winning goodies.
So, without further ado, we would like Ms. Sweta Shaw to kick off this session by introducing smart contracts and Solidity and demonstrating how to create a smart contract for our participants. Ma'am, you are not audible.
Oh, sorry, I was on mute. Yeah.
Yeah.
So, hello everyone. Good morning. How is everyone? And how excited are everyone to learn about Solidity and smart contracts? So, if you're excited, so you can just type in the comments that yes, excited. Yeah. Okay. So, can everyone please put in the comment box? So, do the participants have the access to the comment box? Uh,
Yes, ma'am.
Shrishti? Yeah. Okay, fine. Then can you please write it in the comment box, like which year or which graduation year you are in, or if you're pass out? That would help me in going through the session. I'll modify the session likewise. Okay,
Ma'am, many
fine.
of the people are from third year and fourth year.
Okay. Fine. Yeah,
Yeah.
just give me a moment. Fine. Then let's start the session, and let's see what is blockchain first. Yeah, I'll just share my screen.
Yes, ma'am.
Hey, so everyone can see my screen?
Yes, ma'am, it's visible.
Yes, ma'am.
Okay, fine. So today we will be seeing and learning about smart contracts, blockchain, solidity. I know many of you are excited about how we can write smart contracts, how to interact with blockchain and stuff. Yeah. So let's go through. First understand let's what is blockchain. So basically blockchains are built up of blocks. And what are these blocks? So these blocks contain some data, a hash of the block and a hash of the previous block. So here, what does data contain? So data contains information about the transactions that have been done on the blockchain. Basically, all the information, the storage, everything, the memory, so everything, all the data is stored in these blocks. Hash contains the hash of, these are cryptographically hashed so that the blocks are secure. So this hash contains the hash of the entire transactions that have been stored in this block. Also, it contains the hash of previous block. Okay, so this is important because this is how the blockchains blocks are connected. As you can see, the blocks are connected using this hash of previous block. So this block will contain the hash of previous block, this block will contain the hash of the previous block, and this is how the entire chain is formed. Now these hashes are very secure. These make the blockchain very secure because these are cryptographically hashed. And if anyone tries to tampers with the hash or tries to tamper with the data in the block, it completely changes the hash of that block, and it completely like kills the chain. Okay, and this is how blockchain is secure, because no one can tamper with the data. If someone tries to do it, we can know it. Okay. And by the way, I just want to tell everyone that if you have any kind of doubts, anything, just post it in the comment box. Yeah. So what happened new in blockchain? How it changed the entire ecosystem? So firstly, we will understand about Web 2.0, the traditional application architecture that we have been following until now. So this is how a traditional web architecture looks. So whenever we query anything, it goes from the front end, it goes to the back end, and from the back end, it tries to search the database, and then database returns the like response, and it gets and then it gets shown on the front end. So this is technically how a basic Web 2.0 app architecture looks. But what happens? What happens when blockchain comes into the scenario? And this is how the entire thing looks like. Now, what happens when we query anything from the front end? If we search for anything, the front end goes to the front end goes to the blockchain. It tries to queries from the blockchain about the data that has been requested by the front end. Now, how is the backend system looks like? The backend has Ethereum virtual machine. So this is the EVM that is running on all the nodes, I would say. So here I would like to clarify that blockchain is not concentrated on a single server. The blockchain, the Ethereum blockchain, is running on a peer-to-peer basis on the nodes, and what are these nodes? These nodes are basically individual servers that helps in keeping up the EVM. Okay. Now, how can anyone interact with this EVM? So these happen through the smart contracts. So basically, front end interacts with the smart contracts, like calls functions in the smart contracts. These smart contracts in turn run on the EVM, and then it fetches data from the blocks, and it returns back to the front end. Okay, this is how the entire Web 3.0 architecture looks like. So today's session will be concentrated mostly on writing smart contracts. First, we need to know how we can write a very secure smart contract so that we can interact with the blockchain. So now let's understand what are smart contracts. So basically, smart contracts are programs that run on the blockchain. What kind of programs? We have programs like SQL. We have programs like we write programs in Python, JavaScript, Java. Okay. So what do these programs do? They execute whenever we call their functions, or whenever, or if we have written a script to run on a predefined, after predefined intervals. So things happen like that. So basically, smart contracts are also a program, but where do they run? They run on the blockchain. The way, for example, say if you are having a JavaScript code that is running on AWS, but here the smart contracts run on the blockchain. Now, these contracts, so Ethereum blockchain has accounts. So everyone who wants to interact with the blockchain, everyone who wants to store data on the blockchain or anything, or if you want to have your own wallet, a crypto wallet, everything will have a specific address on the blockchain. Okay. Now these contracts also have a specific address on the blockchain. Basically, address by address, what we mean is having accounts. So even smart contracts have accounts. We will see gradually like how these smart contracts get an address, how we can see those addresses. So basically everything is transparent over here. You can see everything. Next, how to write these programs. So now time comes for some, okay, yeah, basically Solidity. So we write smart contracts using Solidity. And today we will be learning how we can write smart contracts using Solidity. We will start with a very basic hello world program, as everything, as if you are from computer science background. So we start with the great hello world. So everything starts, whenever we learn something, we start it with a hello world program. So yeah. So basically what you can see here, this is a very basic snippet of a contract. The first line here, this is commented, but it is not required. If you don't put this line, they will just give you a warning. But what this line signifies is the kind of license you want to give for your smart contract. Next line is Pragma Solidity, and this some number. This is a version number of the Solidity compiler, and Pragma is a keyword which is used to define what version of the compiler we want to use. Next is this contract hello world. So you will see this structure is basically very similar to a class thing in what we have in Java. Okay, so this basically, if we replace class with contract, this is how the entire thing looks like. So contract is like a keyword which defines that, okay, fine, this is what we are defining after contract is the contract that we want to build. So the name of the contract is hello world, and it has one variable called greet. Greet is a variable, and greet is public. That means anyone can access this variable, and greet is string. Okay, that is greet accepts values of type string. Now next, one more concept over here is that greet is a state variable, and public is a modifier, that is public modifier, and string is the data type, like what kind of values that greet can accept. So we will talk more about what are state variables, local variables in the coming sessions. In the coming slides. First, let's understand that these are the primitive data types that exist in Solidity. Unsigned integer again has subcategories like unsigned int 8, 16 to 56, 8, 16 to 50, going on 16, 32 to 56. So these basically define the number of bits that can be stored by that unsigned integer variable. Again, we have integers which can accept both signed and unsigned values. Again, it has subtypes like int 8, 16 to 56. By default, it will take 256, the highest value. Okay. Next is Boolean. Boolean is true or false. Here in Solidity it takes 0 and 1 as Boolean values. Address is something which might be very new to everyone. Address is used to define the address. So we were discussing previously that all Ethereum So if you want to interact in the Ethereum blockchain, you will have accounts, right? And accounts will have address. So if you want to declare variables that stores the account address, we define that variables as address. Okay, the data type of those variables are address. Okay, I'll take a pause here, Shrishti, to see if anyone has any questions in the comment. Okay, that's cool. Next, we have variables. We will see what are these variables. So variables are of three types: local variables, state variables, and global variables. Okay, local variables are the variables that are declared inside the function. These variables are not stored in the blockchain. Once the function call happens, the function is executed, you won't the variables are not stored in the blockchain. You won't be able to access that variable. Okay, next is state variables. The state variables are declared outside a function. For example, we saw here that this state variable greet, it was not declared out, it was not declared inside the function. Okay, it was declared just like that inside the contract. So variables that are declared like this inside the contract but not inside any function, these are called state variables. Okay, and these state variables, they are stored on the blockchain, and you can anyone can access it. Okay, next are the global variables. So global variables are very important because they help us in querying information about the blockchain. We will get to see what kind of variables these are and how we can use them. Yeah, so let's go through some hands-on session right now for the variables. So here you can see, first let's understand the code over here, and then we can go through and write our own contract for understanding deeply about how variables work, because variables are important undoubtedly. So let's see. First two lines you already know. First line defines the license. Second line defines the Solidity compiler that we want to use. Contract. Okay, by the way, what does this mean is anything Solidity compiler, anything greater than version 0.70 but less than zero point 0.9. Okay, so this is what this means. You can also define compiler in terms of, like, just if you want to use only compiler version 0.9, you can just write pragma solidity 0.9. That's it. Okay, it's not even required to do something like this. Next, this is the variables contract. So here you can see there is a variable called greet, which is of type public modifier, and which is of data type string, and which contains the value hello world. Next is a variable called num, which has a public modifier, and which is of type unsigned integer, and which contains the value 123. So these are basically state variables, and this is a demo function. We will see more about what are these view returns and all so in the upcoming slides, but let's concentrate over here right now. It contains an unsigned integer I, which has value 456. Okay, so this local variable I would not be available to access once you have executed this function or once you have deployed the contract. And these are global variables. What are global variables? You can see block.timestamp. So what does this return? Block.timestamp. Block.timestamp is a global variable which is used to get the current timestamp of the block. Okay, current timestamp means what is the like time at which that block was created. And message dot sender. So this is also new. Message dot sender is the global variable which returns the address of the caller. So whoever is calling this function, uh, it returns the address of that account, I would say. So to understand more and visualize these things, it's better that we go on for a hands-on session right now. So let's open. Wait a minute, I'm sharing. Yeah, let's open this. Let's open this link, remix.ethereum.org. I have posted it in the comment. Sorry, in the chat box. Yeah. Just let me know in the chat if everyone has opened this link. Basically, what this does is Remix. So Remix is an online IDE where we can write our Solidity code and the smart contract. We can write other smart contracts and deploy it and run. No need of Visual Studio Code or anything. You no need of setting up anything on your local Remix IDE. This is an online compiler where you can just write the Solidity code, the smart contracts. Has everyone opened the chat? I mean, opened the link. Okay, fine. So I'll just start going. So this is basically the interface, and this is the workspace where everything is. You can write the contract. So here, this is my previous contract. So I'll just create a new workspace over here. Okay, and you will see by default there will be something. What we can do is just go to this icon over here. It will show you that create new file. Just create new file and enter the file name as something variables.sol. So the extension for Solidity files are .sol. Okay, and now we will start writing. And now we will start writing the code for variables to understand more about how variables work. Okay. Okay, fine. So let's start doing it. Okay, so we will leave the comment thing and start with Pragma. Solidity. You can write the compiler version. Let's use 0.8.0. So in Solidity, what happens is semicolons are important. Every line should end with a semicolon. So we will name the contract. Contract name is variable. So first we will be declaring some state variables, that is string, which is having a public modifier, and the name of the variable is grid, and we will assign the value hello world. Okay, Next, we will be defining an integer, unsigned integer, which is again public and which is of type num. And let's give it a value 1, 2, 3. Okay. Is everyone with me? Okay, okay, awesome, awesome. Fine. So I guess hope you all have done this. Now let's define the function. So let's define the function. Function name is demo function. Okay, and it is public. That means everyone can access this function. And okay, let's do it. It has unsigned integer I. Okay, and let's take a value unsigned integer, and let's take the value. Yeah, the function demo function takes accepts a parameter called value, and we will assign this value to the variable I. Okay, this is just what demo function will do. And here unsigned int I, this is a local variable. Okay, this is a local variable, and here these are global variables. Okay, sorry, I'm extremely sorry, these are state variables. Okay, these are state variables, and these are this is a local variable. And what else, I guess we need to public, and this is a pure function. So I'll talk about what a pure function. Okay. So you see it gives an, so what you can do if you have written the code, what you can do, just press Control S and it will compile your Solidity program. Okay, or you can go here on the left hand side, you will see many icons over here. So there, this is some 1, 2, 3, the third one which says Solidity compiler. Okay, just click there and you can see there's a button called compile variables.sol. Okay, you can just press this and it will compile the program for you. Okay, and you see I am getting few warnings. The first warning is here about SPDX license identifier, since I have not given that. Okay, fine, let's give it. Okay, so fine. So after giving this license identifier, the error has went off. Now let's see what another warning that they are giving is unused local variable. So we can ignore for now this warning because we don't want to use this variable. Okay, and we will learn more about why we have used pure over here in the upcoming slides. So let's try. So this is what basic variables contract we have written, and kudos to everyone. So finally we will be deploying this contract and see how everything works. Next, for deploying, you can go over to your left, this navigation bar, and you can see the last icon that has, and it will say deploy and run transactions. So when you click on deploy and run transactions, you will see this screen over here. So basically this is environment, which environment we want to deploy our contract. So what Remix does is they give us some dummy environments where we don't require a real ether. For example, whenever you try to do some transactions on the blockchain, and what by transactions I mean, if you want to change some variables in the blockchain, if you want to deploy contract, so even deploying contract is called a transaction that you are doing on the blockchain. And doing any sort of transaction on the blockchain, you would require ethers. Okay, it so we will be talking about all those things. So Ethereum, so basically the Ethereum network, uh, there is something called mainnet. So if you want to deploy your contracts on the mainnet, it would require real ethers. But if you want to deploy your contract on the test net, so what Ethereum has done, so most of the blockchain, what they do is they provide mainnet as well as some test nets, or some blockchains call it devnet as well. So what testnet or devnet does is you can deploy your contracts on the testnet to test your application if it's working fine, and you can just redeploy, change things if things don't work. So testnet is for testing purpose. Okay, so once everything is okay and works fine on the testnet, you become sure that okay, fine, now you're ready to launch on the mainnet, because once you launch on mainnet, it's tough to change things over there. Okay, you just can't keep redeploying on mainnet because it would cost you real ethers, and ethers are expensive. So so we will be deploying on the test net. Basically now what Remix has done, they have provided their own local environment which does not use testnet. Also they provide you with dummy accounts with 100 ethers each, so that is really cool. Yeah, right. So you don't need to get any ethers from the pocket, or buy ethers. So they have dummy ethers and dummy accounts that you can use to deploy your contract. We will be using those. And now first let's deploy. So there is a deploy button, and you can select your contract, which contract you want to deploy, and we have variables contract, and we will deploy. Yes, let's deploy. Ye- See, is did everyone deployed? Because I want to see in the chat deployed. Yeah, and kudos to everyone. So whosoever, this is the first contract that you have deployed. Yeah, really congratulations. So did everyone deployed? Nice, nice. I can see deploy. Anaga has deployed. Awesome, Anaga. Congratulations. And we will see next how to understand how global and local variables are working. Awesome, awesome. Okay, I can see just some guy without a face has deployed as well. Awesome, Ankur. Great, great. Congratulations. Awesome, awesome. So after deploying, now let's see how how we can see or understand how these state variables or local variables are working. So as you can see, so in the deployed contract section over here in the left hand side, you will see a little arrow over here. Just click on that arrow and you will see some data about your contract. Okay. So there is great, there is num and a demo function. So why you can see all those things here is because you have made it public. Okay, being public lets the contract show their variables or functions to everyone. So that is why you can see those here. Okay, now if you click on grid, what grid will do is it will return the value that grid stores, and that is hello world. Okay, num, if you click on num, it will show you the value that num stores. Okay, next is the demo function. Now to call the demo function, we will just enter some value over here. what value you want to give, say 100. Okay, and I'll call the demo function. Okay, but you see, nowhere you will get something like greet or num for the variable I, because I is a local variable and it doesn't exist outside this function. Okay, I hope I have been able to make you understand what are the basic difference between state and basic difference between state and local variables. Cool, got it. Now what you can see, there are many more things that is happening. If you click on here, this little arrow, this transaction will expand, and you will see how the transaction looks like. Okay, when we called this function, a transaction happened. Okay, how you will know that a transaction happened? If you scroll this and go to your account, you would see that 100, there were 100 ether over here, but it got reduced to something 99.999 something. Okay, it got reduced. Why? Because when you called this function, demo function, it costed you some ethers. Okay, so yeah, so it costed you some ethers, and you can see the transaction from where it happened. So the transaction happened from account 0x5, and you'll see the same account that is over here. Okay, that means that this account called this function, and it was called to the demo function. Okay, and this is a contract address. So this is the address that the contract got, and you can see the contract address over here, 0xd9 over here. Okay, and execution cost. So now there comes the concept of gas fees. So whenever you do some kind of transactions, it requires some gas. And why does it require some gas? Because blockchain is maintained by all the people in the world who keep up their systems up all the time, and they do some kind of work. Previously Ethereum, I don't want to enter much into that technicalities, just understand that since I know the participants today is a mix of both beginners, intermediate, advanced, so let's keep it really simple. So whoever so blockchain is not, since we know blockchain is decentralized, it is not stored on a single server. There are many people who keep up their computers on, the servers on, just to make sure that the network is on, the blockchain is on. So they need some kind of compensation, right? They like, because it requires huge this is expensive. Maintaining a node is expensive. Okay, it requires high configuration of servers, the CPU, the system memories, everything. So maintaining a node is really expensive. So gas fee is being used to incentivize the, I would say, miners who helps in keeping up the node and helps in verifying the blocks in the blockchain. Okay, and what do verify mean? That so whenever any transaction happens, before it gets entered into a block, it has to be first given a green signal by the miners. Miners are the people who keeps a check if the transactions are legit or is there some fraud happening, stuff like that. Now, when they give a green signal, only then the transactions gets entered into a block and gets registered into the blockchain. Okay, so these gas fees are used to incentivize them. Fine. So much of yeah in one go. I'll take a break or pause to see if you have any questions. Please put it in the comments or the chat if you have any questions. Okay. And first of all, were everyone able to deploy the contract and see and understand how these variables work? Fine. So let's understand. Now we will see how these global variables work. Okay. Okay. Now time for global variables. So we have unsigned integer, timestamp, and this is equal to block dot. Okay. So block is a global variable using which we can get the timestamp of the block. Okay, let's make timestamp public so that we are able to access it. Otherwise, we would not know what is happening in the timestamp. Okay. And one more was message.sender. So let's again. So now we will use this address variable to know the address of the caller. Okay, who called this function. So we will define caller is equal to message dot sender. Okay, what this does is it returns the address of the sender or the caller who is calling this function. We will see how it will work, and now it is no longer a pure function. Okay, again it is giving a warning for unused local variable. Fine, we will, should we use you? Okay, let's let's change num to this value. Fine, cool. So is everyone with me? You can do Control S, or you can go to the compiler and click on the compile button to compile the contract, and you will see a green tick over here that everything went fine with the compilation. Okay. Next, we'll go to the deploy section and try to deploy. Fine. So let's remove the previous contract from here. Okay, otherwise it will just be a make you confused. So currently we have no contract instances to interact with. I'll just go and deploy it. Fine, let's deploy. And awesome. So let's see what we have. So first of all, let's see what grid stores. Grid has hello world. Num has 1, 2, 3. Timestamp would probably be 0. Yes, because timestamp is uninitialized. So by default, it will take 0. Caller, it will take again a 0 address, all things 0 because it is uninitialized. Okay. Next, we will call this function, demo function, with a value, say 100 again. Yeah. And let's see what happens. So also note that what is the amount of ether over here, because it will again get reduced. So let's call this function demo function. And yes, demo function has been called. Now let's see the value of caller. See, the value of caller has changed to this address. This address is same as the address, the account address by which I call this function, and it should happen the same with you. Isn't it interesting, right? So caller was assigned the value from message.sender. What message.sender did is it contains the information about who is calling the function. It takes the account address from there and just puts it in the variable caller. Awesome. Now let's see what grid has. Grid should be unchanged because we didn't do anything with that. Let's see num. Now num is 100 because we changed the value of num to the value that was passed from the function. Now let's see timestamp. Now timestamp is something, so this is a Unix, this is encoded in the Unix system. We need to decode it, changes to like changes to the real timestamp that we use in real life. So we can use it, use JavaScript code or we have libraries to convert it from Unix timestamp to the like the default ones that we have. Yeah. So basically, you see that there has been information that is being stored. So what this did is blocked or timestamp. What this did is it changed the timestamp from sorry it took the timestamp at what timestamp the block execution happened, and it put it to the timestamp variable. So let's again, if we call this function again, so we will see that this timestamp value would change, hopefully. Yes, and this timestamp value changed because now when the function was called, it happened on a different timestamp, and it changed it. Okay, I hope everyone is clear with this. Okay, fine. So if everything is clear with you, everything till now, let's. I want to see the word clear on the comment. I am not saying anything. I want to see that you all are with me. Okay, awesome, awesome. So next we will. So this is a storage app basically. Uh, so what it does is this is something very similar to get a set of functions that we have in other languages as well. So here we have a variable grid with hello world, and this get function, what it does is it returns the grid variable, and this set function, what it does is it takes in a variable grid, and it assigns that grid to the grid state variable. So just a get a set of functions. You can try it out yourself. It will be a nice practice. Yeah. Next, I would like everyone to build a counter app right now. Yes. And what will counter app do? It will have a state variable called count. Okay. And it should have a function called increase and a function called decrease. What increase will do is it will increase the value of this count, and what decrease function will do is it will decrease the value of this count. Okay, very simple, very basic. Yes, I want you all to do it. I'm not going to help over here. Okay, is everyone there on the remix? So you can use this template to make your counter application, contract counter, which will have a state variable count, and it will have two functions, increase and decrease, like whatever you want to name it, increase count, decrease count. Yeah, we have how much? Okay, it should be done by 10:58. Yep, it should be done by 10:58. I'm waiting for everyone. Let's see how clear how clearly you understood the concepts. So if you have any doubts or anything, if you get any error messages or anything, just post it in the comments. Okay, don't just shy away with the error messages, because life of a developer without any error messages is boring. So what we are gonna do is, what you can do is you can go to this, and again you can create a new file from here. Let's create a new file and name it counter.sol, counter.sol, And what we can do is we can copy the license and all from here, and we can define a contract called counter, and we have a state variable called count, which is of type unsigned integer, and we want it to be public, and we want to name the variable as count. Fine. Next, we want to have a function called increase count. Mind it, this is just a template that I am creating. Another is decrease count. Okay. What increase should do is and let's increase the value of count. And what it should do is decrease the value of count. Okay. This is what it should do. Okay, can anyone tell me in the comment what should go over here inside increase count? Tell me, tell me. Okay, the question is what should go inside this increased count? Like what should I write here to increase the count, value of count? What should I write over here? Help me out. So we have a state variable count, and we want to, whenever someone clicks on increase count or someone calls increase count, it should increase the value of count. So basically what it should do is it should increase the value of count by like 1 or 2 3 like any number that you want. Okay, and when we want to decrease the count, what it should do is, come on, now you can tell me this, right? For decreasing count value, what we can do is, so what we can write over here, count is equal to what? So when you want to decrease the count, yeah, so when you want to decrease the count, what we'll do is count is equal to count minus 1. Okay, so it also has a shorthand property, count minus is equal to 1. So this also works. You might have seen this kind of shorthand property in other languages. Okay, let's remove it. Okay, now what is missing over here? We want to make this function as public, right? And what else? And it should be public as well. Yes. Okay. Cool. So did you compile your contract? Let's compile it now and check it. and deploy it. Sorry, I'll deploy it. Let's deploy it. Let's deploy it. And you can see the counter contract in the here on the left hand side of your screen. It has decrease count function, increase count function, and count. So basically when we call count, you will see that value is 0. Now let's increase count. I've increased the count, and now let's check count is 1. Let's increase count again 3 4 5. So I'm just increasing my count, and now the count is 7. Now we will try to decrease count, and by decreasing count we are changing the value of count again to 6. So you can see how it's happening. Is it working for you all? Hmm. Okay, awesome. So did it work? Okay, cool. So let's move to the next slide and let's learn more. Yep. So this is basically the code that we can write for the counter application. Okay, next we will understand about mapping. Okay, mapping is really important. I would say feature of the feature of Solidity. What mapping does is basically, if you know about JSON files, what we do over there, or if you're aware about Python, in Python we have dictionaries. So what we do over there is we store the information in the form of key value pairs. Okay, so mapping does the same in Solidity. Okay, it stores information in the form of key value pairs. So you can see over here in this code that this is a mapping example. Here we have created a mapping from mapping called balances. And what it does is it is storing information from address to integer. What it means that keys will be of type address and the values will be of type unsigned integer. Got it? And let's see how we can implement it, because this is super important. Let's head to our remix again. Let's head to remix and we'll go to files. We will create new file again and call it maybe mappings.solidity. And yes, let's create a contract called mappings with a mapping from, okay, fine, let's call the mapping as balances. What this mapping will do, it will store the amount of balance that all the accounts are having. Okay, so basically keys will be address and the values will be unsigned integer. So I'm just showing over here that how for example, if in JSON we have something called in keys, the keys will be the addresses. So from where we can get the addresses, so if we can go over here and I'll just copy this address. Okay, so what it will do is this will be the key and the value will be balance. So balance can be say 100, and like this it will have, okay, so this is the address again, and this is having 200. Okay, so in this way it will like keep going. So this is basically the structure of a mapping. Okay, and if you want to query, if you want to know the value of this address, you can just call it like the way we call it in other languages. We can use balances or like this balances and put the address of this and put this address over here. Okay, and what it will do is it will return you the value, this value. Okay, yeah, against this key. I hope I was able to make you understand. Let's see how it is working. So this is a mapping called balances. Now what we will do is we will write a function basically and add balance maybe. Wait, wait. And what it will do is add balance. It will update the balance of this address. Do you remember what this message.sender used to do? Message.sender, it used to return the address of the caller who is calling this function. Okay. So what it will do is it will just update the balance of the person who is calling this function, and they can just pass in some value. Okay, and we can assign this value to this. Okay, that how much balance they have basically, and we are making this function public, and yeah, that's it. I guess it should work. Sorry, this is balances. Has everyone written this contract? Has everyone written this contract? Okay, okay, awesome, awesome. Now let's deploy it. Okay, so here on the left hand side of your screen, you will see the new contract called mappings, and let's see what it has. Okay, sorry, we missed adding public over here. So we want this mapping to be public, otherwise we won't be able to see it. Okay, we will compile it again and deploy again. We just remove this one and let's deploy it. Okay, so we have the mappings over here, and yeah, so add balance. So we want to add balance of say 1,000. Okay, and okay, first let's see. So this is the address from which I will be calling this function. Let's first check what balance I hold right now. Okay, so I have balance 0 right now. So next I'll add some balance of 1,000, and I'll write add balance. I'll just call add balance function. Now let's check again what my balance is. So see, now my balance is 1,000. Okay, works. Okay, now fine, let's call it. We're using another account. So you can choose the account using which you want to call the function. I'll choose the third account, and let's call add balance. I'll add balance of say 2,000 right now for now, and I'll call add balance, and it must have added my balance. I'll copy this account and I'll check my balance from here, and see, you can see I have a balance of 2,000, right? So it's working. So did anyone understand how this mapping worked and how values are being assigned? Yes. Fine. Awesome, awesome, awesome. Now we will talk about view and pure functions. Okay, so you might have seen that there were places where we declared some functions as view and some functions as pure. Now what are view functions? So we used view functions where those functions didn't modify anything that was stored on the state, or say state variables. Okay, so view functions, what they do is they do not modify any state values. Okay, and what pure function does is uh, Yeah, and view function can read the state variables. View functions can read the state variables but cannot modify the state variables. Okay, and what pure function does is these functions can not only modify the can not only modify the state variables, they can also not read the state variables. Okay, they can neither read the state variables nor they can modify the state variables. Okay, and what view function does is view functions cannot modify the state variables but they can read the state variables. Okay, okay, we can just see how this happens. For example, we were um, so let's declare a function called get num. Okay, what this function will do is it will return unsigned integer. Okay, what it will do is it will return the value of this num variable. And so for returning the value of this num variable, this function will just be reading the state variable. Num is a state variable and it will just read the state variable. Hence, we would have to make it a view function. Okay, and also make it public so that we can call the function. This is public view, and what it will do is it will return the num. That's it. Cool. And we have another function uh, called say add numbers. Okay, what it will do is it will take in two values, say num1 and another argument called num2. Let's make it public function, and it is a pure function. And okay, it will return again the sum of these two values. So it returns unsigned integer, and it should return num1 plus num2. Cool. Cool. So did everyone write these functions? Okay. So you might have doubt like why did we write view and why did we write pure? So let's remove this view and see what happens. Okay. And let's remove this pure and compile this. We got an error. Sorry, a warning. Okay. What the warning says is function state mutability can be restricted to view. So it automatically detected that this function is not modifying the state variable. It is just reading from it, and it is asking you to make this function as view. Okay. Similarly, over here also you will get a warning to make the function as pure, because this the compiler automatically detects these kind of issues, and it will suggest you to make it either view or pure. Fine, let's deploy it. Let's deploy this contract and let's see. We have function called get num. Okay, see, for get num function you don't have any input over here because it is not accepting any parameters. If you call get num, it will just return the value of the number. Okay, see, number is 1 2 3 and you are getting 1 2 3. And for add nums, you are just adding two numbers, it's 100 and 200, and you call it, you will get 300. Okay, because add nums is not reading, neither it is reading any state variables nor it is modifying any state variables. It is just working with the values that were sent with the function. Okay, so this kind of pure function, now you might have a question that when these pure functions are required. Okay, so these pure functions are required or say is used basically when we define the libraries. Okay, so for example, you're writing a Solidity like full application. Okay, where you want to have your own library that does few kind of utils library, which might add few things, or modify the numbers in certain way. So in those kind of functions, you require few pure functions, where it might not modify the state, it might not read the variables from the state, but it does the work with whatever is passed through the function. Got it? I hope it's clear. Now we are moving towards the towards the end, or I would say the project that we would make today. And today we will be launching our own crypto token, a coin. Okay, so isn't it interesting? So how many of you have already how many of you have already experience in launching your own crypto coin or token, or you say ERC20 tokens? So basically we will be writing a ERC20 contract right now. Are you excited to launch your own crypto coin? Okay, okay, that's cool, that's cool. So how many of you know about MetaMask? Mm-hmm. How many of you know about MetaMask? Awesome. So MetaMask is basically, so if you see here, this is MetaMask. Okay, I need to write my password. Okay, so this is my MetaMask in which I have some ETH over here. So these are basically the okay. So here you were saying that we had got some ETHs over here, 100 ETHs, dummy ETHs for interacting with the contract or doing any kind of transactions. So when you write it in so when you use some Visual Studio, or if you want to deploy these contracts to say testnet, you would require this kind of it's okay. This is for Rinkiby test network. So we have many test networks over here. So you can just use MetaMask for interaction with the uh, Ethereum blockchain. Now, next question is how to get these ETHs. Okay, so you can use this. So you can go to this link, and from here you can get the dummy, or I would say testnet ETHs, okay, to interact with the blockchain. So you can select the network that you want to be in, or you can connect your wallet and it will transfer the. So I will connect my MetaMask. Okay, and here they will provide you 0.1 test ETH, and it detected my wallet address, and it will send me. I'm a human, I'll do some kind of checks, so which I'm not going to do right now. And you can click on send request to get some testnet ETH. Okay, and then you can interact with the contrast or do some interactions. Okay, so anything that you do on Rinkiby, so rinkiby.etherscan.io. So this is a website where you get details of all the transactions that are happening on Rinkiby. You can wait a minute, I'll just show you. This is my account address, I mean wallet address, and you can go to this explorer, paste your account address, and you can see what kind of interactions I did basically. Okay. So this is all. So next what we will be doing is creating our own ERC20 tokens. Okay, so basically what are ERC20 tokens? These are basically the coins that you see. There are many ERC20 tokens like USDC or Dogecoin or anything ERC20. So let's understand what are ERC20. So this is the official Ethereum website where you can see they have they have explained very beautifully what is ERC20 token. Okay, so ERC20 is basically a fungible token. Okay, by fungible what do we mean is if I have any ERC20 token and if you have ERC20 token, the value of both the token will be same. For example, if I have launched or say USDC. Okay, there's a token called USDC. If I have two USDC and you have two USDC, the value of both will be same. Okay, unlike NFTs, NFTs are ERC721 and crypto coins or crypto tokens are ERC20. Okay, so yeah. So these what they do is, since there are so many blockchains, so many blockchains that are there in the ecosystem. There is Polygon, there is Ethereum, there is I would say Clayton. So there are numerous blockchains that exist. But how so there should be some standard of these tokens, right? That this token should have this properties. Only then it will be only then it will be liable to be called ERC20 token. Okay, so for this they have provided that these contracts should have these functions. Okay, name, symbol, decimals, total supply, balance of transfer, and everything. Okay, got it. So we will understand what these things do. So these ERC20 smart contracts, this should implement all these functions. Only then you can call your contract or token as ERC20. Next, it should also implement two events. I'll talk about events. What are events in a short while? Okay, so let's start building our own cryptocurrency or token. For this, I have prepared a short snippet. Uh, So if you can go to this GitHub link, I'm just posting it over here. Okay. Okay. So if you can go to this link and you will see that I prepared a template for you all. So today we will be trying to implement this and see how everything happens. Okay. So a part of this we will do it today, and the rest will be your assignment, basically the project. Okay, so let's start. So let's create a new file again, and this will be my, let's call it my crypto token .sol. Okay, so we'll just copy the license and this from here, and we will name the contract as my crypto token. Okay, and first of all, every ERC20 token should have a name and decimal. Okay, name and symbol. Okay, so what does name means? Name here stands for the name of the token that you want to give. Okay, so I'll give the, and it should be public. because it will be accessed by everyone. So string public and name of the token. Okay, the name of the variable is name. So this is fixed. Okay, this is fixed. So even here you will see. Sorry, where it is. Yeah. So this is fixed. Okay, name. So I'll name my token as blockchain devs, and I will name the symbol as bdev. Next, what is the method that we want to implement is a mapping. Okay, so mapping will be required to store the balances. Okay, because ERC20 token, you know, so ERC20 token is basically this token. This contract will hold information about everyone who holds this token. Okay, so that is why we require balances to store information about how many, to store about who who are the people who hold these tokens and how much. Okay, so we will use that mapping from address to unsigned integer, and this is balances. Okay, this is done. Next, what do we need? We need address of the deployer. Okay, who is deploying this contract? So the person who deploys this contract becomes the owner of this uh, token basically. Okay, and when we will be deploying this contract, the deployer will have some initial amount of these tokens on in their account, because that's true, right? If I am creating some token, I will first fund myself some amount of token, right? So is everyone with me? Any doubts or anything? Please post it in the comment, please. I would love to clear all the doubts and everything. Okay, next we have a constructor. So if you know, like in other languages, also we have constructors. Similarly, even in Solidity, we have a concept of constructor, which gets called every time we deploy the contract. Okay, it is called only once when we deploy the contract. Okay, so what we will do is in the constructor. So what we will do is in the constructor, we will set the deployer's address as the message.sender. Okay, the person who is deploying the contract, and we will assign balances to this deployer. Okay, as okay, something in the sort of this much into 118. Okay, why I did this? Why I did this is because if you go over here and if you see, there's a concept called Fini, ETH, okay, Ether. So the way we have these unit systems, SI unit systems for maybe length and mass. Okay, so for example, for length we have millimeter, decimeter, decameter, like centimeter, like all those things. In the similar fashion, even Ether has their own unit system, where V is the smallest one and Ether is the largest one. Okay, and it goes like V, then GV, then Fini, and then Ether. Okay, and one Ether is equal to 10 to the power 18 V. Okay, what I said is one Ether is equal to 10 to the power 18 V. Okay, And Solidity smart contracts, they understand everything in terms of V. Okay, so if I wouldn't have done this, they would consider this as a V, and this much V is basically how many ethers? It would be very less, like really, like 0.00000 something ether, and that makes no sense. Okay, so that is why we multiplied it with uh, one like 10 to the power 18 over here, so that even if so that this much V is equal to this much ether. Did you guys get it? Okay, so we have the balances set. Now next what we need to do, we will be implementing this function called function name. Okay, what it does is it will return the name of the token. Okay, so function name, what it will do is it will return the name of the token. Okay, it will return name, and it should be public, and it should returns. Okay. Okay. Yeah, so what it is warning, what it is saying, that it can be restricted to view because we are not modifying the state variable, we're just reading the state variable. Okay, cool. So I'll talk about memory a bit later. Okay, like what this memory is being used for, and then a function symbol for returning the symbol of the token. In next, what we have is function decimals. So this will define the decimals of the, for example, what I mentioned before, just a few minutes back, that one ether is equal to 10 to the power 18 V. So this 18 is called the decimals. Okay. Uh, so basically for our own token, we can define how many, like what decimal we want to use. We can use 10 to the power, we can just use 10 to the power 8 or 10 to the power 1 or 0, anything. Okay, so for now we are going with what Ethereum does, what Ether does. They have decimal 18, so we will be using decimal as 18 as well. And it is again view returns an integer, and it will return 18. Okay, it should be pure because it is not even reading from the state variable. Cool. And total supply. Hmm. Next, we have a function called balance of. Total supply will implement a bit later. Okay, we have next what we have balance of. So what this function will do is it will return the balance of a particular address. Okay, what it will do is it will take address owner. So this is one thing in Solidity that we follow whenever we want to use any variables or arguments inside a function. We declare, like we put a underscore in front of it to signify that this is a parameter. okay, and not a real variable. So what it will do is it will return what it will do is it will return the balance, which is of type unsigned integer, and it should return balances of the owner. Okay, we need to make it public, and we need to make it view because it is just reading and it is not modifying anything. Okay, next balance of. Next we have transfer function. So what transfer function does is it will move amount token from the to amount. Okay, from caller's account to the to. So it will take address to and the amount that needs to be transferred and the amount. Okay, and this should be public. And what else? Yeah. So what it should do, transfer, is it should decrease the balance of message.sender by this amount. Okay. And in turn, it should increase the balances of the to account, right? So this is how transfer should work by the same amount, right? I think for now this would suffice. Hmm? So let's compile it. Let's compile this contract and deploy it. So yes, I have deployed this contract and here is my crypto token. So what is the name? So name of my token is blockchain devs. Symbol is bdev. And what else? So this name function will return the name of the token. Decimal will return 18. That is the decimals. Also, I deployed it using my account, this account. So let's see the balance. What balance I have? So I have this much V. So mind it, this is in terms of V. Okay. Now I want to transfer this to some other address. Okay. So I was using the third account. So let's transfer this to this account. So let's copy it and let's transfer how much I want to transfer, say 100, and let's transact. Okay, so transaction happened. Now let's see my balance again. See, my balance decreased by 100. Okay, and let's check the balance of this account. Is this the one that balance of this? See, that account now has 100. Okay, so previously it was having nothing. So let's check that again. So let's see for some new account. Let's see for this account 0x61. So if we check the balance of this account had zero balance, but then I am transferring 100 to, say, for example, say 500. Okay, 500 to this account, and I transacted. Okay, Okay, the call function should be payable. Okay, okay, fine. Let me check once. Okay, because so this error happened. What it said is that it transaction reverted, and what it says that the call function should be payable if you send value, and the value sent should be less than your current balance. Okay, so why did this error happen is, see, the balance of this account is 0, and I was trying to make this transfer from this account only, okay, which like where I have 0 balance, so that is why it got reverted. So let's do it using this account, the account using which I deployed and I have balance. So next I will transact, and this transaction happened, and now let's see, this account has 500 balance because we transferred just now. Cool. So this is so everything here happened locally on remits. We can also do one thing, we can deploy these using MetaMask. How to connect MetaMask with Remix is, you can just go over here and you can choose this option, injected provider MetaMask, and what it will do is it will connect your MetaMask over here. Okay, now when we try to for this I'll just name IEEE SIESGST. I hope I have spelled it right, and let's do it. I Yes. Is this correct, right? This is correct. I hope so. Okay. So, and now I will be deploying it on Rinky so that we can check it. Okay. Let's deploy it. So now what it will do is it will open my MetaMask, and from my MetaMask it will ask me for transaction. I'll confirm my transaction. So creation of my crypto token is pending. So let's see. So this contract deployment is pending. It will take some time for the transaction to be successful. And yes, it got successful. We'll see it on Blockchain Explorer. So it is indexing. It will take a while. Awesome. And this is the contract that was created. Okay. So this is a contract that was deployed for this. Cool, awesome, awesome. So with this, we have come towards the end of the session, and the floor is all yours, to ask any questions that you have. But before we go to Q&A, let me tell you a few things that what the project is all about. Now the project is about, since we implemented few of the functions, your task is to uh, implement the remaining ones, okay, and make it a fully fledged ERC20 token contract. Are you getting it? So let me try. Assets. So but why does it taking BDAV? It shouldn't take BDAV, right? Okay, I got it. I didn't. Okay, I didn't compile it here. No, okay, I got it. So let's deploy it. Okay, wait a minute. It should be decimals. And the interesting thing is that you can check your token that you just deployed in your MetaMask. Wait, I will show you. Deploy. Let me deploy it. And whatever other functions that you want to be added in for your token, you can just add it in the form of functions. And the project is about implementing the. Okay, it got deployed. Let's see. So this is a contract for your token. Okay, the contract has been created. Now we will copy this contract for the token, and we will try to import. Okay, we will import the token that we just created. So see, it automatically took this. Okay, it automatically fetched the symbol and the decimal from the contract that we just deployed, and we'll just add this custom token and see I have this much balance, and I just import it. Yeah, isn't it interesting? So anyone, I would like to send this token to you folks. So can anyone put? So do you have MetaMask first of all? So if you have MetaMask, can you give me your account, like wallet address, so that I can send it to you? So that I can send it. And for sending, I would require your account address. Okay, fine. Okay, so if I would have got this. Cool, awesome, awesome. So if I would have gotten this, so no issues. It's awesome. So yeah, fine. That's totally fine. Yep. Cool then. So your task is to implement the other functions. So for example, we have balance of function, we have transfer function. We have another function called transfer from, where you need to put the address of from address, the to address, and the value that you want to transfer. There's some concept of allowances over here. You can need to implement these functions, increase allowance and decrease allowance and everything. So if you have any doubts or anything, you can just come over here in this GitHub repository. You can create issues, or you can comment, or whatever you can do over here. You can create issues. I will be happy to answer all your queries over here. Just fork this repository and implement these functions. After implementing these functions, you create this file in your own GitHub repositories, and I guess the host will share a link with you for submitting your project. So just share the GitHub link with them. Yeah, that would work. And I'm happy to answer any questions that you guys have. Yeah.
Yes, ma'am. Thank you so much for introducing us to this amazing workshop. Hopefully, our participants must have grasped some interesting knowledge on this topic.
Now we will begin with a brief Q&A session. So if you guys have any doubts or questions regarding the topic, feel free to comment down your queries in the chat box.
Okay, so we have a question from Sahil Seni. Just like we deploy dApps on the Ethereum network, when will it be possible to do the same on the Bitcoin network?
Okay. See, Bitcoin network was designed just for the transfer thing to happen. So right now we wrote our own ERC20 token. We had this transfer function. So unfortunately, the Bitcoin network doesn't allow anyone to, have to net other people to write their own smart contracts and deploy over there. It doesn't support. Yeah, so that is where Ethereum came in, and the blockchain ecosystem just boomed. Yeah.
We have a question from Faidan Kalan. What are the alternatives of Solidity?
Okay, for solid alternatives for Solidity, now that depends on the network that you want to work with. So if you want to work with any EVM based blockchain network, for example, Ethereum or Polygon or Platin or Celo. Okay, there are many blockchain networks, EVM based blockchain networks. So for them, you can use Solidity or Viper. Viper is also another programming language that can be used with the EVM based networks.
Okay, next question is from Anushka Gaikwad. What languages can smart contracts be written in?
Yeah, it can be written in Solidity and Viper. This is I am talking about if you're writing smart contracts in Solidity. Sorry, for Ethereum or EVM based chains, you can write it using Solidity or Viper. If you're using, if you're trying to do it on Solana blockchain network, so that ecosystem is completely different. Yeah.
So next up we have Sanika Hiroji. What are the variables influence the amount of cash in use during a transaction?
So I would say variables per se don't influence gas, but the kind of transaction or the execution that will be performed in the backend. If the execution is a system heavy operation, and it requires a lot of resources, that would cost a higher gas. And if it's a simple function, just a normal modification or something like that, it would require a lesser amount of gas. Yeah, so that is why it is said that when you're writing in smart contracts, it is important to write gas it is important to write smart contracts in a way so that those are gas optimized. We need to optimize the contracts so that it requires less amount of gas. Yeah.
Okay, so we have one question from Kiran Pal. What are the requirements for deploying a smart contracts on the Ethereum network?
Okay. First of all, you need to have an account for wallet, for example, say MetaMask or Wallet Connect, anything that does. So mostly developers prefer MetaMask because that is easy to use. And then you need to have a good smart contract that is written, and that's it. You can deploy it the way I showed just now, like few minutes back, using Remix. Yeah.
Okay, ma'am. Thank you so much for your time.
We do like to thank ma'am for joining us today and addressing and enlightening the participants through this interesting workshop on solidity and smart contracts. Ma'am, we would like to present you with a small token of gratitude from our side.
Oh, thank you so much.
Yes, ma'am. Would you like to speak a few words before signing off?
Yeah, I would say that I saw a few questions over here, like how to get started as blockchain developer. So first of all, like I would say, keep practicing, keep making projects because projects are important. Keep building a proof of work because whenever you go outside, that is what it will require. Because, resume and all is good, certificates and all is good, but proof of work, once you have a proof of work that you built something, that speaks a lot in itself. So yeah, keep building.
Thank you
And if
so
you have
much,
any
ma'am.
issues, any questions, just I guess hosts have my details or email IDs. You can just contact me. Yeah.
Yes,
Thank you
ma'am.
so much.
Sure. It was really helpful. Yeah. So guys, it's reward earning time. Buckle up to attempt this project. The link for submission which you can access in the YouTube live chat box. We will also be dropping a feedback link after the end of the session of day 2 which will also earn you points. Give your best and collect points for maintaining your rank on the leaderboard. Thank you so much ma'am for this amazing session. I guess the audience have gained a lot of information.
Thank you, ma'am.
Thank you.
Thank you ma'am.
Thank
So, this amazing session has now come to an end. We thank you, ma'am, for giving us your valuable time and your cooperation to be a part of Epsilon 2022. As we have an interesting workshop on cybersecurity coming up, where you will get to learn cybercrime investigation using OSINT. We would also like to express our gratitude to our sponsors for their support, starting with IMFS, our title sponsor, the first institution in India to provide expert coaching for exams including the GRE, GMAT, SAT, TOEFL, IELTS, and PTE. IMFS, which was founded in 1997, they offer expert counseling session as well as a platform with a large and active alumni network and strong connections to more than 500 institutes globally.
Next up, we have our educational partner, Aurora Coaching. The goal of Aurora Coaching, a crypto coaching firm, is to inform and raise knowledge about the world of cryptocurrency among both individual and organizations so that both can approach it with confidence.
Our streaming partner is StreamYard. On the StreamYard platform, you may broadcast over social networks directly from your browser. Before choosing the premium plan, to gain access to more features, it provides a free option that you may test out.
Thank you for being such a great audience. We wish you all the luck for your upcoming endeavors and hope to see you in our next session of Epsilon 2022. Thank you all.
Thank you, everyone.